All right, so in 8.2, we are looking at the interest problems. The first one we're going to look at is simple interest, where the interest is calculated only on the amount of money that we invest or the amount of money that we borrow, called the principal. So the formula is I equals PRT. I is the interest earned, P is the principal, the amount borrowed or deposited. R is the interest rate. We're going to write it as a decimal, and T is the time in years. So our first example, if we deposit $500 in a bank account paying 6% interest, how much interest will the deposit earn in 4 years if the bank computes the interest using simple interest? So on example 1, we are looking at using our I equals PRT. We need to know what the P is, the R is, and the T is. So that's coming from our problem. So we're depositing $500. That is the amount that we are investing, depositing, or borrowing, whichever way you want to look at that. So P is going to be $500. Our rate, it's paying 6% interest, so that's 6%. And the T in that is going to be 4 years. So you need to remember that you have to change this to a decimal. So when you move it over to, you're going to have to insert a 0 there. So it'll be 0.06 will be our interest. So using our formula, I will be equal to our $500, so that's our P, times our rate of 0.06 times 4. And so our interest is going to be $120. So for future values, the future value using simple interest, we're going to find the future value of an account that pays simple interest using this formula of A equals P times 1 plus RT. So again, A is going to be the accumulated value, P is still your principal, R is still your interest rate written as a decimal, and T is still your time in years. So example 2, we are assuming that you deposit $1,000 in an account paying 3% annual interest for 6 years. Use the simple interest formula to calculate the future value of this account. So for example 2, we are looking at the formula of A equals P times 1 plus RT. So we need to figure out, we're trying to find the future value. The future value is going to be the accumulated value. So we are looking to know what the P is, what the R is, and what the T is. So the amount that was deposited was $1,000. Our rate was 3%, which we need to again change with our decimal places, so it will be 0.03. And the time in is going to be 6 years. So A will be equal to 1,000 times 1 plus 0.03 times 6. And you can put that in your calculator all at one time. And your accumulated value will be $1,180 or $1,180. And that's at the end of your 6 years. All right, example 3, future value, present value we're looking at this time. So assume you plan to save $2,500 to take a white water rafting trip on the Rio Grande River in New Mexico in 2 years. Your bank offers a certificate of deposit, which is what they call a CD, that pays 4% annual interest computed using simple interest. How much must you put in the CD now to have the necessary money in 2 years? So we are looking at how much do we actually have to put in now. So we're looking at what is our principal that we're going to put in. That's what we're trying to find. All right, so if we look at, we're using the same formula for example 3. And in this case, if we're looking at the accumulated value, the amount that we need at the end of the 2 years is $2,500. That's how much we need to go on our trip. The rate is 4%, which would be 0.04, and we have 2 years to save it in. So we're looking for P. So A is equal to P times 1 plus R times T. So A is 2,500 equals P times 1 plus our rate of 0.04 times 2. So what we need to do is divide by everything that isn't P. So that 1 plus 0.04 times 2 on both sides. So our P will be equal to 2,500 divided by the 1 plus 0.04 times 2. And that should get you 2314.81. So that tells us right now we need to put in $2,314.81. It's because the interest rate is so low that we need to have most of our money happening in there. And we're only doing it for 2 years. All right, so compound interest is our next thing that we're looking at. Compound interest is interest computed on your original investment as well as on any accumulated interest. The formula for compound interest after 2 years with the balance, A in the account with principal P, and an annual interest rate of R, again will be in decimal form, is given by A equals P times 1 plus R over N raised to the NT. A is the amount in the account. P is the principal, which is the same thing that how much did we put in or how much did we borrow. R is your rate in decimal form. T is the time, the length of the investment. N is the number of compounding periods per year. So for your accumulated value, it is the value of the money that accumulates over time. The number of compounding periods per year, if it's annually, that means it happens once a year. So it's 1. Semi-annually, think about that as a semicircle, a semi-truck. That happens 2 times. It's got 2 parts. It's twice a year. Quarterly, how many quarters are in a football game? How many quarters are in a dollar? There are 4 of those. Monthly, well, there's 12 months in a year, and weekly there would be 52. So for example 4, you have seen a home fitness center on sale for $3,500, and what really makes the deal attractive is that there is no money down and no payment due for 6 months. Realize that although you do not have to make any payments, the dealer is not loaning you the money for 6 months for nothing. You have borrowed $3,500, and in 6 months your payments will be based on that fact. Assuming the dealer is charging an annual interest rate of 12%, compounded monthly, what interest will accumulate on your investment over the next 6 months? Alrighty, so let's go look at example 4. So for example 4, we are looking at all the values. We are trying to find what interest will accumulate on your purchase over the next 6 months. We're looking actually for the interest, not the total accumulated value, but we're going to have to find the accumulated value and take out what we borrowed to find the interest on that. So if we're looking for all of our letters, remember our formula is A is equal to P times 1 plus R over N raised to the NT. So A equals, we have P, we have R, we have N, and we have T. So we don't know the accumulated value. That's actually what we're looking for. The principal is the amount we're going to borrow, and the amount that we are borrowing is the $3,500 for the home fitness center. The rate is 12%. Changed to a decimal would be 0.12. The number of compounding periods, which is our N, it's happening monthly. So monthly means it's going to be 12. And the time is 6 months. Remember our T, our time has to be in years. There are 12 months in a year, so 6 over 12 will get us 0.5 years. So it's half a year. All right, so we're looking for A. That's the one we don't have. So A is equal to 3,500 times 1 plus our rate of 0.12 over 12 raised to the n, which is 12, times our t, which is 0.5. When you plug that in the calculator, you will get $3,715.33. This is our accumulated value. Now, to find the interest, we need to take the accumulated value and subtract out the original principal to find how much we actually accumulate in interest. So we're going to take 3715.33 and subtract out our original principal, which will get us $215.33, and this is the accumulated interest. So that's how much you're going to pay in interest over that 6-month period. So always pay attention to what they're looking for. Are they looking for an accumulated value? Are we looking for the accumulated interest, or are we going to find the principal? So in the next problem, upon birth of a child, a parent wants to make a deposit into a tax-free account to use later for the child's college education. Assume that the account has an annual interest rate of 4.8% and the compounding is done quarterly. How much must the parent deposit now so that the child will have $60,000 at the age of 18 to pay for college? So this will be example 5. So in this case, we're actually looking at how much does that parent need to deposit in the account. So if we list all our letters again, the total amount we want to accumulate is that $60,000. That's how much we want in the account at the end. We are trying to figure out how much should we put in the account now in order to have that in 18 years. The interest rate is 4.8%, which will then become 0.048. It is compounded quarterly, so that tells us it's 4, and the time is 18 years because that's how old the child will be when they're wanting the $16,000. So the one we're trying to find then is our principal. So A equals P times 1 plus R over N raised to the NT. Plugging in what we know, 60,000 is equal to P times 1 plus 0.048 divided by our N, which is 4, raised to the 4 times 18. Now again, we're trying to solve for P, so we're going to divide by everything that isn't P, and I'm going to change 4 times 18 and make it 72 because that'll make it easier. So 1 plus 0.048 divided by 4 raised to the 72, because that's 4 times 18, on both sides. You can figure out part of this individually, but do be careful about rounding too soon because that'll change your answer. So our P will be equal to the 60,000 divided by the 1 plus 0.048 divided by 4 raised to the 72. And you should get $25,418.76. So this is what you must deposit now. So you're going to have to put in $25,000 in order to get $60,000 by the time they're 18 because of the small interest rate and the number of compounding periods.